Good afternoon, everyone. So welcome to my YouTube channel, Avatarm. So today we are going to see lecture number of how to find number of terms in a given GP. Okay. Till now, if you have not subscribed my YouTube channel, subscribe it for such type of interesting lectures. Okay. So let's start today's session now. Okay. So GP is of two types. GP, geometric progression, is of two types: infinite GP, okay, and second is finite GP. Finite GP. So what is infinite GP? A GP, a geometric progression, GP, in which there are infinite number of terms is called infinite GP. Okay. For example, okay, 1, 2, 2 square, 2 cube, and this is going. Okay. We have not mentioned here that it is terminated after certain stage. So this is infinite GP. Okay. Second example, you can take 1, 3. Okay. Sorry, 1, you can take 3, 6, 12. Okay. 12, 24, 48, like that. So this is also infinite GP. This is also infinite GP. So what is finite GP? GP. A GP in which there are finite numbers of terms is called finite GP. Okay. For example, I am taking this 1, 2, 2 square up to 2 to the power 9. Now you see that there are finite. I am taking power 2 to the power something power. Okay. Some power. So this is finite because last term is 2 to the power 9. So this is finite GP. Okay. You take this example: 3, 6, 12, 48. Okay. 48. Okay. And you take this. Okay. And you last term you take 9. 192. Okay. So this is also finite GP because last term is 92. 192. Okay. Okay. So note that number of terms always found in finite GP. Okay. Is number of terms is always found in finite GP. So in infinite GP, because this is suppose some GP is infinite, so how we can calculate how number of terms in infinite GP? Because there are infinite numbers. So what is that? So we can only calculate how many terms a finite GP has. So this is possible in only finite GP. So finding number of terms is only allowed in finite GP. Okay. So number of terms in a finite GP. Okay. Let A1, A2 let A1, A2, A3 like that. Okay. And some term AN is given. So this is finite GP B given. Okay. Okay. So how to find number of terms? Let this GP has n. Okay. Finite GP is given. Suppose some B is given here. Let this GP has n terms. Okay. Let this GP has n terms. Then what is the last term of this GP? Then last term is, because if this GP has n terms, what will be the nth term? Nth term, last term will be nth term. And what is the formula of nth term? AR to the power n minus 1. Okay. So last term is B. So this implies B is equal to AR to the power n minus 1. Okay. Now this GP is given. You have a first term, you have a common ratio. So you know, we know B, A and R. Okay. And R. Therefore, solving equation star, we get number of terms in the given GP. Okay. So it will be clear by example. Okay. It will be clear by example. How? So example I'm taking, first example I'm taking, how many terms the given GP has. And what is the GP is given? GP is given 2, 1, 1 upon 2, 1 upon 4, and this is given 1 upon 128. Okay, solution. So given GP is 1, 2, 1, 1 by 2, 1 by 4, 1 upon 120. This is finite GP because last term is 120. Finite GP. Finite GP. Okay. So what is the first term 2, and what is the common ratio? First term is A is equal to, what is common ratio? So is equal to R, that is common ratio is R is equal to 1 upon 2. You divide second term by first one or third term by second. In this question it is given that this is GP, no need to check. Okay, but if it may ask that it is possible that you have given a progression, and it is not mentioned whether this is GP or not, but you will have to check whether this is GP or not. Okay. So here it is given in question that this is GP, so no need to check. Only you take ratio of second term with first one, that is 1 by 2. Okay. And what is the last term? Last term is 1 upon 2/8. Okay. That is my B. I'm saying this B. Okay. So let the number of terms in this GP is N. Okay. Then what is the last term is B, that is nth term. What is the formula for nth term? AR to the power n minus 1. So this is 128. So put the value of A 2. Okay. What is R? R is 1 by 2 to the power n minus 1. Okay. How I can write 1 upon 128, 2 to the power 7 it is. And what is this? I can write 2 to the power, I can write, what is this? 1 upon 2 to the power n minus 1. How can I write this? 1 upon 2 to the power n minus 2. Okay. 1 upon 2 to the power 7. Comparing both the sides, power. So what you will get? 7 is equal to n minus 2. After solving it, you will get n is equal to 7 plus 2. This is n is equal to 9. So this GP has how many terms? This GP has 9 terms. Okay. It is clear? Okay. Now move to second question. Okay. How many terms are there in the given progression? Okay, 2, 5, 10, 20, 40. Okay, last term is given 5, 1, 20. Okay. So in this question, it is not given that this is GP or not. We have to check 5, 10, 20, 40. This is first term A1. This is first term, second term A2. This is third term A3. This is fourth term. Okay. This is last term. That is my B. Okay. What is A2 upon A3? A1 upon A2, that is 10 upon 5. That is 2. What is A3 upon A2? That is 20 upon 10. That is 2. Okay. What is A4 upon A3? 40 upon 20. That is 2. Okay. And so on. It is going. So you see that we have what we have, that A2 upon A1, A3 upon A2, and A4 upon A3, and so on. This is nothing but 2. Okay. This implies this is GP. Okay. GP. And what is the common ratio? Common ratio is 2, because this is ratio A2 upon A1, that is 2. And what is the first term? First term, A is equal to first term is, that is 5. Okay. Let this GP has n number of n terms. It has n terms. So what will be the last term? That is my B, and B is given nth term. What is B? B is given 5, 1, 5, 1, 2, 0. And what is this? A r to the power n minus 1. So what is A? This 5. And what is R? R is 2 n minus 1. Now cut this. 1, 0, 2, 4. Okay. This implies. Now, how can I write in the power of 2? Okay. 2 to the power 10 it is. Compare the power. Okay. So what is n? N is 10 plus 1. N is 11. So this GP has 11 terms. Therefore, this GP has 11 terms. Okay. Now move. We will see next question. Example 3. Okay. Example 3. What is that? How many terms the given progression has? Okay. 2, 6, 18, 54, and last term is what? That 4, 8, 6. Okay. Solution. Two, 6, 18, 54, 4, 8, 6. So this is finite GP. Okay. This is finite GP. Okay. So now this is, we have not checked till now whether this is GP or not. So first we have to check this is GP or not, because in question it is not given. Okay. So what is the first term? 2. What is the second term? 6. Okay. What is the third term? 18. The fourth term? 54. And this is last term. That is my B. Okay. Okay. So what is A2 upon A1? Tell me. 6 upon 2. That is 3. What is A3 upon A2? 6, 18 because A3 is 18, A2 is 6. What is this? This is also 3. Okay. What is A4 upon A3? That is A4 is 54, A3 is 18. That is 3. Okay. And you continue like that. Okay. So what you got? You got that A1, A2 upon A1, A3 upon A2, A4 upon A3. This is nothing but 3. Okay. So this implies this is GP. Okay. This is GP because common ratio is this progression has a common ratio, that is 3. Okay. So it means this is finite. This is finite GP. Okay. What is the first term? Now, what is the first term? First term is what is first term? Let's see. First term is this. Okay, 2. So first term is 2. What is R common ratio? What is common ratio? Common ratio is A2 upon A1. Now we have checked this is GP. So A2 upon A1, what is that? Or you take A3 upon A2, or you can take A4 upon A2. What is that? 3. Okay. Okay. So we got first term and common ratio. Okay. So let this GP has n number of terms. Okay. This GP has n number of terms. What was this GP? 6, 8, 18, 54. Last term was? Let's see what was the last term. 4, 8, 6. Okay. So if it has a finite number, n number of terms, what will be the nth term? So this is nth term. Okay. So last term is B, that is nth term, that is AR to the power n minus 1. Okay. So what is last term? 486. 486. You put the value of A. A is 2. What is R? R is 3. N to the power. Okay. Okay. So bring to this side. Okay. So what is this? You cut. It will be 2, 4, 3. 2, 4, 3. 3 to the power N minus 1. I can write this, what is this? 81 into 3. 3 to the power N minus 1. So what is 81? I can write 9 square into 3. Now 3 is 3 square. So it becomes 3 to the power 4 into 3. 3 to the power N minus 1. Now what is this? 3 to the power 5. Okay, comparing both the sides power, what you will get? So 5 is equal to N minus 1. So this implies N is equal to 5 plus 1. That is N is equal to 6. Okay, N is equal to 6. So this we have, it has 6 terms. Okay, so in this lecture, what we have learned? We have learned how to find number of terms in finite GP. Finding number of terms is possible only in finite GP. It is not possible in infinite GP. Okay. So thank you very much for today's lecture. Like, share, comment and subscribe my YouTube channel. If you have any problem or issue related to this lecture, you can comment me on my YouTube channel. Feel free to contact me. So thank you very much for today's lecture. Thank you very much. We will see you in next lecture. So goodbye for next class. Okay. Oh, sorry. Goodbye for this class. We will see you in next class. Thank you very much.